Hey there, Algebra 1. So hopefully you have completed this already. I am just going to go ahead and I'm going to solve through some of these and you're following along to check your work. As always, if you have any questions, you are welcome to either pause this video, copy some things down, or email me and we can go over some questions. So this first part is that we're going to go ahead and we're going to solve these quadratics. Now these methods for solving that we've been working with are factoring, square roots, completing the square, or quadratic formula. So if I zoom in a little bit here on one, I notice here that I can go ahead and I can use factoring for this guy. And that's because I have a lovely GCF. And always, I'd love to check that we can factor anything because it makes solving so much easier. So my GCF for this guy is 4x, meaning that if I factor out a GCF of 4x, I'm left with x plus 2, and that of course is equal to 0. And this is why we love factoring so much, is because now we're able to split up these two factors and use that zero product property, meaning that 4x is equal to 0, or x plus 2 is equal to 0. I'm going to take my first one and divide by 4, meaning that x is equal to 0. Subtract 2 on both sides, and x is equal to negative 2. So these are my two solutions. We have x is equal to 0, and x is equal to negative 2. I'm going to write that down here on the bottom so that we have everything ready to go for our second part. Okay, so that's number 1. We solved number 1. Now I'm going to look a little bit at number 2. And what you might notice about number 2 is that this x squared is the only variable in the equation, meaning that it's missing that bx, and that we're able to solve by square roots. So I'm going to make a note here that there's no bx term. And when there's no bx term, we just try and isolate that x squared. X squared is equal to negative 3. Take the square root of both sides. There's a negative in the square root. So for right now, that means no real solutions. So for down here, I'm going to put none, meaning that this is not going to cross the x-axis. Okay, so here's number 1 and 2. Number 3. So the thing that I like about number 3 is that my leading coefficient is 1 and that this middle term is an even number. That means I get to use completing the square, and as you all know, that is one of my absolute favorites. And I love completing the square because it seems so, it's kind of like methodic in terms of when you're solving this guy. So we go ahead, we have 8x squared minus 8x, leave a space, is equal to negative 5. And now we have to add that certain number, which is negative 8 over 2 squared. And if you already felt like doing that mental math, you would have said x squared minus 8x plus 16, because that's negative 4 squared, which is 16. On the other side, negative 5 plus 16 is 11. You also could have factored at that step, and you hit x minus 4 squared is equal to 11. And you'd go ahead, you'd take the square root of both sides. Now this one's not negative, meaning that you can take the square root of 11, but it's as simple as it can get. You're going to go ahead and say x minus 4 is equal to plus or minus the square root of 11. Add 4. X is equal to 4 plus or minus the square root of 11. So for our solutions, I'm going to go ahead, I'm going to write that one down here at the bottom. But we also kind of want to think about what those numbers mean. And if you wanted to go ahead and use a calculator, switch over to the dark purple, you would have said it's about 0.6, and I think it's also around 7.3 for that guy. So just some decimal approximations. And the reason that I went for decimal approximations is because you might have said down here at the bottom how we have the graphs, and based only on our solutions from these guys, what color do I want to choose? Choose the salmon color. So only on our solutions are we going to go ahead and we're going to look at these problems. So on number 1, I said x is equal to 0 and x is equal to -2. So I'm looking at my equation here, y equals 4x squared plus 8x, and if you'll notice on letter C, your solutions or your roots are -2, 0, and 0, 0, meaning that number 1, the graph is C. I'm also going to write that on our graph so that we keep track. That's equation number 1. On equation number 2, we went ahead and we had no solutions. So y equals x squared plus 3. And it still has a graph, but if we'll notice here, it's not crossing the x-axis, meaning that there's no solutions for it. So number 2 turns out to be A. So I'm going to write that again on our graph as well. And process of elimination here, you would have seen that for our solutions for 3, you could have guessed that it's B, but if you'll notice, those decimal approximations add up to that graph there. So number 3 is graph B. And a lot of times on Desmos, when you see those decimal approximations, you can kind of assume, not all the time, but you can, for the most part, that they do have radical solutions. Okay, so we're going to go ahead and we're going to look a little bit at our word problem here on 4. And it is a challenge, so if you had some problems with it, that's okay. But we're going to go ahead, we're going to work through this guy together. So I'm going to read it for you. A farmer has 100 feet of fencing to make a rectangular pen for his animals, and it's against the side of a barn. The barn will create one side of his pen, and he would like to know the best dimensions to make the pen. Okay, so he has a total of 100 feet of fencing, and he wants to know the best dimensions. So if you'll see here on this drawing over here on the side, is that if you added up all of this black fencing that I'm highlighting right here, you would get a total of 100 feet, because that's how much he has to make this. So let's go ahead and let's start following directions here. A says label the short sides of his pen X. So this side is going to be X, and because it's rectangular, the opposite side is going to be the same length. So for instance, if one side was 10, the other side would also be 10. One side was 15, the other side would also be 15. They have to be the same exact length. Now, for this long side of his pen, this side right here is kind of interesting, because if we take up this side, the short side, and we also take this short side, but we only have 100 feet to go ahead and make this, is that we would end up having 100 minus 2x. So whatever the length is of this guy, it's going to be 100 minus 2x. Okay, so now we're going to go ahead and we want to write a function for the area, a of x, of the pen. And hopefully we remember from middle school is that the area of a rectangle is your length times your width. So length times width. And for our function, we have a of x is equal to what I'm going to say is x times 100 minus 2x. Okay, so when we go ahead and we actually simplify this guy, we have a of x is equal to, and we have negative 2x squared plus 100x. Okay, now what you could have done here is that you could have done a few things, but we're going to do this a little bit mathematically. Now for D, we're finding the dimensions of the pen that create the largest. Another word for largest could be maximum area. Hey, maximum and quadratics, we know how to solve for those. My maximum is going to be my vertex. So this is why quadratics are so cool and helpful, is that we can find the vertex of a of x. I'm going to write a of x again here. A of x is equal to negative 2x squared plus 100x. In order to find my vertex, I need to go ahead and I need to say x is equal to negative b over 2a, meaning that x is equal to negative 100 over 2 times negative 2. And when we go ahead and we solve for that, we have negative over 100 over negative 4 is equal to a positive 25. Okay, so meaning that my x value is going to go ahead and be 25. All right, for right now, I don't have to go ahead, I don't have to find the y value. I just need to know that x is equal to 25. So going back to my drawing over here, I know that x represents my short side. So the dimensions of my pen should be 25 feet by, now for this side I have to do a little bit of math. So we have 100 minus 2x, 100 minus 50 is 50, so 25 feet by 50 feet. And that is going to create the maximum area for my pen. And if we go ahead and we solve that, we get 25 times 25 times 50, and that gives us 1,200 and, oops, sorry, undo that, 1,250 feet of area feet squared for his animals. Okay, you can go ahead, you can put your pencil down for a second. I do want to show you this in terms of Desmos really quickly. And I'm going to go ahead, I'm going to plug in that equation that we had. So we had x times 100 minus 2x. And this parabola here is kind of cool. It's really, 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 really big because as we found out is that the maximum area here is at this point, let's see if we can pull it up, 1,250, meaning that a width of 25 creates an area of 1,250, which is pretty cool that we figured out what kind of area we needed to do in order to solve for that farmer to create his barn. Okay, so when we go ahead, pick up your pencils again, follow along with us in terms of matching our parabolas. So we're on the back side of this paper. I'm going to switch back to pink. And we have all of these equations here, and we have some clues that we're working through. So I'm going to go ahead and I'm going to look to see if I can figure out some clues and start crossing off some problems. So I have a y-intercept of 3. A y-intercept of 3. So I'm going to go through my equations, And this c is the only one where my constant is 3, meaning that I can go ahead and I can say c. Cross that guy off. I have a vertex of 1, -5. All right, I'm going to come back to that one. I open downward. Okay, so if he opens downward, we know that it needs to have a negative leading coefficient. D is the only one with a negative leading coefficient. We can do that one. I am the narrowest parabola, so the most skinny, meaning that we're going to go ahead and we're going to look for a big number as A. If you guys can see, this guy has 7. That's a really big number. So we're going to go ahead, we're going to choose F for 8. I have no x-intercepts. No x-intercepts means that we're not crossing the x-axis. So the graph would not cross the x-axis. I'm looking through here, and if you'll see, this guy is x squared plus 4. So if I tried to solve him, I'm going to go ahead, I'm going to set equal to 0. If we subtract 4 on each side, this is going to leave me with that negative inside the radical, meaning no solutions. So A is 9. All right. Ooh, I make a line. A line. So I'm looking for the one that's not a quadratic. Hey, this guy has a degree of 1, meaning that it will create a line. Okay, we have roots at -2 and 3. This guy's in root form, B. And if we went ahead and we solved them, we would definitely get that 0 is x plus 2. We would get that -2 and 3. That leaves us with B. And by process of elimination, we know that this guy is G, but let's go ahead, let's just check it. In order to find my vertex here, I would need to use x is equal to -2 over 2 times 1, meaning that I get a 2 over 2, that's 1. And when you plug 1 into this guy, you should get -5, and you do, meaning that G should be 6. Okay, so I'll leave that up there for a second for you to double check your answers. And that's pretty much it for our parabolas. Now the second part is some review for you. So let's go ahead and let's look a little bit at our review. Okay, we put up all these methods of factoring up here at the top. So we have GCF, difference of squares. Remember all these guys? You can factor your trinomial. You have a perfect square trinomial and grouping. Okay, so let's go ahead. Let's start factoring these guys. For number 12, I like that GCF. Has a GCF of x. So when you factor out an x, you get 16x plus 17. There's nothing else that's common about that, so that's as simple as we go. I'll switch to a different color of highlighter here. Maybe I'll use green. And that's our final answer. Okay, let's look a little bit at 13. It's definitely a trinomial. However, if you'll notice, we also have a GCF in here. So I'm going to start with my GCF. Oopsies, sorry. Which is 3. So we have 3 times 2x squared minus 13x plus 6. Okay, so then after we factored our GCF, we want to go ahead and we want to check this middle trinomial here. And we can set up that middle trinomial with our diamond. And I have 12 at the top, negative 13 at the bottom. I'm sure that you guys got this, which is a -12 times a -1 Don't forget to drop your 3 down there because that's still part of your trinomial. And I'm going to set up these parentheses with our rainbows. I know that you guys are fans of putting that large number at the bottom. Okay, so kind of using these guides, I know that 2x times negative 6 is going to get me a negative 12x. That leaves me with an x and negative 1. And we go ahead, that definitely works out. I'm just going to go ahead, I'm going to rewrite it over here on the side so that we can all see the final answer, which is 3 times 2x minus 1 times x minus 6. I'm going to pick that highlighter that we've been using. And there, that's as factored as I can get it for that guy. Okay, 14. Lots of factoring. Lots of GCFs. We like all the GCFs that we can do. Oh, this guy doesn't have a GCF. However, there's something that's really special about these two terms. And hopefully you picked it out. Is that guy has a perfect square of 5x. This one has a perfect square of 4. We know that 5x times 4 is 20. 20 times 2 gives us that 40, but we need to go ahead and we need to connect it with this sign. So that perfect square trinomial, 5x minus 4 squared. And you guys are really good at figuring out that perfect square trinomial. I think that some of you guys did that for your project and you did a great job. Okay, we just have a few more here for factoring. Hey, this is a ding-dong, and I know that's a ding-dong because it's 2 perfect squares, x and 9, and we connect 1 with a minus, 1 with a plus, and we are completely done for factoring our ding-dong or difference of squares. Last guy here for factoring. It's 4 terms. We've done pretty much everything else. We're going to go ahead. We're going to group this buddy. 4 terms, I'm automatically looking to group. There is a GCF in these first 2 terms. Hopefully you see it. So 9x cubed plus 45x squared. That gives me a GCF of 9x squared. We are left with x plus 5. All right, then we look at our second one. So we have a negative 4 for our GCF, x plus 5. And now we see that I have a GCF again. That GCF is that x plus 5. So we have x plus 5, and then you write what you're left over with. So 9x squared minus 4. Uh-oh, ding dong. Because you always want to check to see if you can factor more. And a 9x squared minus 4 is definitely a ding dong, because 9x squared is a perfect square of 3x. 4 has a perfect square of 2. Connect 1 with a plus, 1 with a minus. Now I can use that green highlighter because this is as factored as I can go. Whew! You guys are doing a great job of following along with this worksheet. We have 4 more problems to do. We got to solve some quadratics. It is like algebra that we love. So we put these little check marks here to remind us that we have 4 ways of solving, and we're going to look at number 17. I hope you notice that we have this x plus 8 squared, meaning that I for sure am going to solve by square roots on this guy. Follow along with me. I'm adding 9 to both sides. We have negative 4 times x plus 8 squared is equal to a negative 40. You might be concerned that we have the negative 40, but when you divide by the negative 4, that turns into a positive 10. Take the square root of both sides. X plus 8 is equal to plus or minus the square root of 10, and I know I'm going kind of fast here, but that's because I'm hoping that you've already solved these and that you are simply using this video as a check. This, for sure, I'm going to switch over to green again, is my final answer. X is equal to negative 8 plus or minus the square root of 10. Okay. And again, I'm going to kind of go fast on these guys because I'm hoping that you've already tried to solve them on your own. So looking at this guy, I have a bx term. I can't use square roots. I can't need to, in order for my other guys, be able to set equal to 0, meaning that I have to move this 10 over to the other side. 4x squared minus 13x plus 10 is equal to 0. And this is where you kind of want to check to see if it can be factored. So we definitely want to try to factor. So we have 40 up at the top, negative 13 at the bottom. And if you think about those factors, well, I can do a negative 8 and a negative 5. So this guy can be factored. Set up our rainbows here. It's kind of squished in there. But from here, you can think about your factors for negative 8x. That's going to be a 4x times negative 2. Leaves me with an x here and a negative 5. Okay, it's a little messy, and I apologize for that, but we can do 4x minus 5 and x minus 2 for my two factors, leaving me with 4x minus 5 equals 0, x minus 2 equals 0, and you get to solve both of these linear equations. So x is equal to 5 over 4, add 2, x is equal to 2, and these are my two answers. Back to green, we have x is equal to 5 over 4, and x is equal to 2. We solved this guy by factoring. We could factor that guy. Always try factoring. It ends up being kind of the easiest method if you try it out. Okay, for this guy, if you'll notice, all of these are divisible by 3. So I'm going to divide them all by 3 to make everything a little bit easier to see, leaving you with x squared minus 6x plus 11 is equal to 0. And when you solve this guy, you can see that this negative 6 is even. I definitely love completing the square. How many times do you think I can say that during this video today? So x squared minus 6x, leave a space, is equal to negative 11. I'm going to add that special number, which is negative 6 over 2 squared, plus negative 6 over 2 squared. Do some mental math for yourself. We have x squared minus 6x plus 9, negative 2. So x minus 3 squared is equal to negative 2. But when you take the square root of this guy, it's that negative. you run into a problem here, which is that you have no real solutions. Hint, hint, see you in Algebra 2 when we talk about that guy. Whew. Last one. Hang in there with me. You totally got this. Okay. For this guy, I'm definitely going to go ahead. I got to move this 5x over so that we are setting it equal to 0 before we start, and we can decide from there what we want to do. If you set this guy up for factoring, you end up with a -7 at the top, -5. I don't know about you, but I can't think of those numbers. So that looks like we're going to go ahead, we're going to use the quadratic formula on that guy. And that's because this -5 in here is an odd number. We'd end up with fractions with completing the square. No fun. So I like to go ahead, I like to say my A, B, and C so that I don't get confused over negatives. And if you wrote the formula, bravo to you. X is equal to -b plus or minus the square root of b squared plus 4ac all over 2a. Let's start plugging in some values. So I know that x is equal to -5 plus or minus the square root of -5 squared minus 4 times 1 times -7 all over 2 times 1. All right, so we have, once we get rid of those negatives times negative, and inside our square root we have 25 plus, because the negative times a negative is a positive, 28 all over 2. We end up with x is equal to 5 plus or minus the square root of 53 all over 2. And that ends up being my final answer because 53 cannot be simplified. I don't think I'm going to highlight this in green over here. And that is your note worksheet. I hope you stayed with me the entire time. Great job and good luck on your quiz this week.